Hello, this is Mrs. Taylor, and I want to introduce you to how to find the area between two curves. So the idea is that we know how to find the area of some geometric shapes, but what happens when we have a really complex region that we want to find the area of, which is a more realistic idea, seeing as how a lot of the areas out there in the real world aren't perfect squares or rectangles or triangles to begin with. So we already know how to find the area between a curve and the x-axis, which is through integration. So that's where we have some curve on the x-axis that I want to find the area below. And so we just understand that to be the region, the region enclosed by that curve and the x-axis. But what happens if I have a different shape? So let's say it's something like this, and I want to find the area of that. Well, if you think about it, that really is the area enclosed by two curves. So if I can find some kind of function to represent the curves, then I can use calculus to find the area between them, and therefore find the area of this complex spleen-looking, kidney-looking region. So that's what we're going to do. So formally, the area between two curves can be found in this way. If f and g are continuous, look, I forgot an n. If f and g are continuous with f of x greater than or equal to g of x, throughout the closed interval a to b, then the area between the two curves y equals f of x and y equals g of x from a to b is the integral of the difference of f and g from a to b. And so notation wise it looks like this. The area equals the integral from a to b of f of x minus g of x dx. So basically, visually, what they are communicating here in words is that every y value of f is greater than or equal to every y value of g. So graphically, that could look something like this. If I have some curve that I will label as f of x, so that's this curve here, and then some curve that I will label g of x, but all of those y values have to be less than or equal to f of x. So somewhere down here, less than my original. So that would be g of x. And so really, visually, it looks like top is f of x, bottom is g of x. So a lot of times we just say top minus bottom, your top curve minus your bottom curve. And that's really what f of x is greater than or equal to g of x is communicating. And so to find the area between them, really all I have to do is integrate from some a value to some b value and subtract the two functions as part of my integral, and that'll give me the area of this region enclosed by the two curves. So it's kind of like a formula, which makes this really easy. The difficult part, or what can be difficult, is just figuring out what's top minus bottom. So let's dive right in. Find the area of the region between the two functions on the given interval. Y equals secant squared x and y equals sine of x. And the interval is from 0 to pi over 4. So without graphing, we need to determine what the top and bottom curve is here. And if you think through what you know about your trig functions, you'll be able to do that. So think about sine of x, and sine of x bounces between two values, 1 and -1. And from 0 to pi over 4, it's even more narrow than that. So when x is 0, sine is 0. And then when x is pi over 4, sine is square root of 2 over 2. secant squared x is 1 over cosine squared x. And so cosine of 0 is 1. 1 squared is 1. So this bounces between 1 and pi over 4. So cosine of pi over 4 would be square root of 2 over 2 squared, which would become 2 over 4, which is on the bottom, so it would be 4 over 2, which is equal to 2. So secant squared, 1 to 2, is going to be greater than sine of x on this particular interval. So that means secant squared x is my top function, and sine of x is my bottom. So setting it up in the integral that we just were given, I would say the area between these two curves is equal to the integral from 0 to pi over 4 of top minus bottom, so secant squared x minus sine of x all times d of x. And when I integrate, you may think, oh, trig's terrible to integrate, but these are actually really straightforward integrals. The integral of secant squared x is just tangent x, and the integral of negative sine of x is cosine of x. So this is equal to tangent of x plus cosine of x, and we will evaluate on our limits of integration. So tangent of pi over 4 would be sine of pi over 4 over cosine of pi over 4. Well, both of those equal square root of 2 over 2, so that would equal 1. Cosine of pi over 4 is square root of 2 over 2, and then minus tangent of 0, which is 0, cosine of 0, which is 1. And so I would have my 1 minus 1 cancel, and this would be equal to the square root of 2 over 2. So, area between curves, basically you set up your integral on the interval given, and you find your top curve minus your bottom curve, integrate, evaluate, and you're done.